Good morning to all. I'm Niveta. We are going to see interfacing, that means keyboard interfacing with 8051 microcontroller. This is a matrix keyboard. It's a type of keyboard layout where the keys are arranged in a grid of rows and columns. That means the connections of rows and columns. The keyboard has a multiple rows and columns with each key located at the intersection of a row and column. Each key is connected to a switch that is activated when the key is pressed. The keyboard is scanned by applying a voltage to each row and a column in a sequence, allowing the microcontroller or microprocessor to detect which key is pressed. The scanning process means the microcontroller or microprocessor applies a voltage to each row in a sequence while checking the columns for a signal. When a key is pressed, the switch key is closed and the signal is detected on the corresponding column. The 8051 microcontroller or any of the microprocessor which identifies the pressed key based on the row and column numbers. In this diagram, keyboard interfacing, the rows are connected to an output port and the columns are connected to an input port. When a key is pressed, a row and column make a contact. Otherwise, there is no connection between rows and columns. If all the rows are grounded and the key is pressed, one of the columns will have a 0 since the key is pressed provides the path to ground. If no key has been pressed, reading the input port will yield ones for all columns since they are connected to VCC. From this, the rows are connected to a output and grounded, and the columns are connected to an input that all are connected to the VCC. If any key is pressed, the columns are scanned again and again until one of them has a 0 on it. After the key press detection, it waits up to 20 milliseconds for the bounce and scans the columns for again and again. After 20 milliseconds delay, the key is still pressed to goes to detect which row it belongs to. To detect the row, it grounds one row at a time, reading the columns each time. If all columns are high, the pressed key cannot belongs to that row. Therefore, it grounds the next row and it continues until it finds the row the key press belongs to. After finding the row, it sets up the starting address for the lookup table that holding the ASCII codes for that row and it goes to the next stage to identify the key. Now it rotates the column bits one bit at a time into the carry flag and checks if it is low. When carry flag is 0, it pulls out the ASCII code for that key from the lookup table. Otherwise, it increments the pointer to point to the next element of lookup table.